Hi, my name is David Ryan, student number C00198292, and welcome to my Christmas lighting scheme tutorial for first year Introduction to Electronics. Today I'd like to give you an overview of the following: the scheme in full, an individual lighting scheme of my choice, how I link them together, findings and issues, discussion, and I'd like to end the video with an overall conclusion. Before we move forward to which scheme I chose, I would like to give you a brief introduction to each mode. The modes are as follow. Reading from left to right, top to bottom we have the walking one, the Knight Rider, the accordion, the ROM, the mix, the fast Knight Rider, the time scheme, and finally the BCD counter. Although each scheme had several different components, each with their own difficulties, the scheme I chose for this tutorial is the ROM. Here I have the ROM scheme, ROM standing for Read Only Memory. I'd like to introduce all components used on the clipboard, U1 being the ROM chip, U2 being the binary counter. To the left of the binary counter we have the clock. For the purpose of this video, the clock is set to 2 Hz. The clock is also connected to the up of the chip. Below these we have 3 logic states, one connected to the down, one connected to the preload, and lastly, one connected to the master reset. For every clock pulse, the chip will count up. For this to work, we need the logic states to be a 1 in the down, a 1 in the preload, as it is an active low and we're not inputting any data, and a 0 on the master reset. Above these, it is worth noting the D0, D1, D2, and D3 are the data input pins. This is where you would input the data if you were to preload. Moving to the right of the IC, we have the Q0, Q1, Q2, and Q3. These are our output data lines, and the Q0 being the most significant bit. Below these, we have our terminal count up and terminal count down. These signal when the chip has either reached its max count or min count state. It is also worth noting that these are active lows. Moving on to the ROM. On the lower end of the ROM chip, we have our control lines. It is worth noting that 2 of these are active lows. CE bar is our chip enable, and OE bar, which is our read. These are for the chip to be able to access address lines, read the data internally, and see the data on the output. Above the control lines, we have 4 connections from our counter to our ROM chip, Q0 to Q3, and A0 to A3. This is also known as the address bus. The address bus can access address lines inside the ROM chip. Because the counter can only count from 0 to 15 in binary, it can only access 16 address lines inside the ROM chip. Moving to the right of the ROM chip, D0 to D7 is our data lines, or data bus. This executes the internal data for display. Following our data lines, each will be connected to a 330 ohm resistor along with an LED. The LEDs will display the sequence, all these in which are connected to ground. Before I play the sequence, I would like to show the 16 address lines I entered into the ROM. This was made in application Notepad. Each line had a byte made up of 8 binary digits. As the chip reads from right to left, the addresses are as follow on screen. For example, when we press play on Proteus, the clock will pulse. This will start the binary count 0000. In turn, this will transfer through the address bus and access address line 1, which will read the data and transfer it over to the data bus. The length of time this takes is called latency. The data bus will output and display all active highs. In address line 1, this is the first LED. Next, we'll have the clock pulse again, and in turn we'll count up 0001, which again will transfer through the address bus and access address line 2, which again, reading from right to left, will display LED 3. This will continue until the counter reaches its max count state, 16, and will restart the process again. Next, I would like to show you how I program the chip. First, I would start by right-clicking the chip, edit properties, select the folder image, and inside there is a notepad file I saved with the data entered. Click on this, open, and notice 4.bin. From research and from trial and error, this file will not work, and you will need to enter a comma, caps lock, ASCBIN after this. ASCBin is simply the binary code chart for the address bus going in. To help the read access the address lines, the lines need to be called ASCBin. Once it recognizes the address lines, it will proceed with the program. Next, I would like to show you the scheme working in full. As we look at the binary counter and the ROM chip, the red dots signify a 1 or a high, while the blue dot signifies a 0 or a low. I'd like to show how I link these together. Each wire is labelled, which means it's connected. 8 multiplexers, 1 to 8 mux table for display purposes, 8 display LEDs, schemes marked 0 to 7, our switch, which consists of a counter, LCD, and a master switch, logic states and logic toggles, which are connected accordingly throughout the scheme. Our master switch is connected to the up of the counter, which is to scroll through our schemes. Our output pins on the counter, Q0 to Q2, are connected to the LCD, while Q3 is connected to the logic toggle, which is a 0. This means when it hits 111 or 7 on the counter, it will go back around to 0, which is the walking 1. Our multiplexers on the input have X0 to X7, X0 in each being connected to the walking 1. For example, Y0 is connected to X0 on the first multiplexer, Y1 is connected to X0 on the second multiplexer, Y7 is connected to X0 on the last multiplexer. We have A, B, and C, which is also connected to the output pins of the counter, A being the most significant bit. Active low, chip enable, Y and Y bar. Y on the first multiplexer is connected to the first LED. Y on the second multiplexer is connected to the second LED. As we move down to our mux table, if we have 0, 0, 0 on our counter, it will access X0 on the multiplexers, which will display 0 on our LCD, and in turn will display the walking 1 on our 8 LEDs. This will follow suit from X0 to X7 and then come back around. Issues I had when making the project were, when putting all schemes on the same clipboard, I had to replace nearly all the chips. Copy and paste method did not work. This took quite a while. While doing this, I also learned how to label each wire. This made the project much tidier. Discussion. The only thing I would change would be, as making each project weekly, I would put each into the final clipboard, as this would save a lot of time at the end of term. To conclude, Although this was a very demanding yet rewarding experience, I learned a great deal from both this project and the making of this video. Thanks for watching.